Hi, I'm Guo Cheng Guang, 12 years old, secondary 1 from NUS High School. Right now here, we are still going on with our theoretical mechanics. But this time of theoretical mechanics, we are at chapter 1, as there's actually a lot of things that we need to clarify. There's a lot of things that we still have to learn inside this first chapter. So this first chapter about kinematics. So we're already until part 10. Part 10 is actually about free fall. But wait, does it always have to be falling down? What if we just throw something up, or we just use a gun and shoot upwards? Also possible for that, right? So yes, we can use those type of examples. Okay, and we've actually explained about the different things that we will use when we're using for going upwards. So right now here, well, to show that we know how to use all those, we're giving different examples of how we could actually use those. So to solve like different examples, and yeah, they're different. So they might ask us to find different things. So right now here, I'm just assuming that there are two guns. Well, of course, they're actually just right at the same place. Or perhaps it's just one gun set with different speeds to shoot this bullet or the ammo. Then at this part, this gun firstly shoots one bullet. This one first bullet goes up at the speed of 300. So I'm just going to use now the meters per second. So I'm just going to use this first. So 300 meters per second. That's for the first bullet. Then after that, after it waits, so how about let me just give a longer time interval, 5 seconds. So this is 5 seconds later, it shoots another one. And for this second bullet, it shoots at the speed of 500 meters per second. So that will be what we have here. Then, for this part, we are going to find the time it takes for this second bullet to catch up or collide with the first bullet. So just like at the same displacement for that part. So right now over here, this is 5 seconds later. Let's think among the 3 formulae that we have. So for 3 formulae that we have over here, the first one, Vt is V. Okay, so this is the terminal velocity, and Vo is the initial velocity. Then you have to subtract. So as this part is At. So that's, wait, this A, for which is actually acceleration, well, in this part, we're just going to use G. And for this part of G, we're just going to use 10. But wait, what's the unit of this? 10 meters per second squared. So we're just going to use this for the acceleration here, okay? So that's the first formula that we have. For the next will be something about its displacement, h. And for this part that we're going to have, let's see. So this is h, but beware, right now here, we do have an initial velocity, we do have this terminal or ending velocity or final velocity, whatever you call that. So for this first part, the initial velocity times the time, then beware, this, because it's going upwards, but the gravity x, pulling it down. So you have to be aware that this part will be a negative. So this part you subtract half gt squared. That's what you have for the second part. Then the third formula well, it will not include time. So at this part, what will we have is this terminal velocity square. You subtract initial velocity square. What you get will be negative 2gh. So these are the three that we may need to use here. So let's see, what will we need to use? So this, when they meet each other or the behind one catch up, that means that displacement is the same already. So since the displacement is the same, we could calculate the displacement with this. We're given this initial velocity for both. We're also given this g. The next part, time, well, that means there's only one so-called variable over here. And in fact, we also know the difference in it. So there are actually two ways from this. Whether you want from this first bullet, that means the time you start calculating is from this first bullet, or the time you start calculating for what the last answer is from the second bullet or the last bullet. So there are different ways here. Let's just say we calculate from the first bullet. For the first bullet, that means it will be 300. So 300. So we're just going to use t. Since we're calculating it for the first bullet. So at this part, we need to subtract. So 5 and t squared. And this displacement is equal to the displacement for this second bullet. So the second bullet here, we were 500 is now the initial velocity. And in fact, this time, since it starts 5 seconds later, so this part we need to subtract 5. This is what we will have for this first part if we're calculating it like this, and it's for this first bullet. Well, it's at last the time that you're calculating for, it just starts straight at the first. So from this part, we're just going to solve these equations here. So from these parts, so this first part we already have our 300t and our 500t. Then from this part behind we already have our negative 250t. I mean here don't have a t anymore. But this part behind, yes, we do have another constant, that's why I've combined them with. Then beware, there's still one more term with t from this part. So the negative is add. So for this part, you add 50t. But just beware of that. These two parts, the 5t squared, they cancel out. So just making some other calculations here. So, at this part. So, it will be around this part. So, this time, which starts from this first bullet, will be 10.5. If you're calculating for the second bullet, then you have to subtract 5, which will be a 5.5. Remember, this is for the first bullet, okay? This is for the first. Always be well what you're using it for. First bullet, if second bullet, then you subtract 5, okay? So I have to be really clear of these parts. Well, this is one case over here. We start 5 seconds later, and this second bullet caught up with it along its way up. How about we try a bit later? Let's try different cases here. We can play around with them. How about 10 seconds later? So we're just trying, would it be more of a different case? Would there be different types of cases that's happening here? So if this part is 10 seconds later, this goes up. So there are different ways of calculating for this first bullet. So if you want a second bullet, then you add a 10 here. So the first one, 300. Or you can still use t if you're calculating for the time starts with the first bullet. Then you subtract. So this part behind is still the same. Then after that, this is 10 seconds later, so you need to subtract 10. Then after that, this part also subtracts 10. Okay, so that's what I have here. So 300, 500, so you still get 200. 5t squared, 5t squared, well, they'll cancel out since both are negative and are on different sides. Then next for this part, here you get a negative 5,000. Here you get a negative 500. So subtract 5,500. Then after that, you get negative 20, then times 10. So then you will add 100. 100t over here. And this is equal to 0. So for your 300t, it will be 5500. So t will be 55 over 3 seconds. That is what you have if you're going with the first. So that is what you have for this part. Well, and this part. How about let's play a little bit more. We make it even more later. So here is only 10.5. Here is around 18 point something, okay? So after that, we make it even more later. So how about 20 seconds later? 20 seconds later, it goes all the way up. Wow, this is the first part. Then this is the other part for the bullet with speed of 500 meters per second at first. So we're still going to make different calculations here. So that's what you have for this part. Here is like this. Then for t, what you'll have will be 30 seconds over here. this number looks very perfect. So your time for this part, well, it is still from the first bullet. So basically the total for this part is a 30 seconds, including this waiting time for the second bullet. So 30 seconds. So what could be so special about this 30 seconds? How is it just so perfect at that? What if we just think about something with this first bullet. This first bullet, since it just shoots very early, let's think about some other things that we can get from this part. Well, if it shoots up because it just keeps on slowing down. Wait, when it keep on slowing down, that means there is definitely a limit for its height. So there's definitely a point where it will go down. Well, of course, it will sort off while then it goes down. But wait, let's check, is it in any one of these places? In case if it is this question came out just so perfectly. So at this part, we're just checking out whether that's all. Since there are different cases, it can be this first bullet is still going up, then the second bullet overtook it. It can be the first bullet is just going to stop, then the second bullet came. It can be the first bullet is going back down, then the second bullet went over it. That means at this part, 30 seconds. So if you try to put it inside there to calculate for its terminal velocity, so this part is just a 300 minus 10 times 30. If you sub inside here, that means it will just be a 0 for its velocity. And that means this part is actually very special here. It is just as this first bullet, it is about to stop. So in this example, I'm just going to give for these three cases. 2 of them are the same, one of them is quite special. So right now here, I'm just going to end this lesson here, and I hope that you can understand so far. So we'll see you in the next lesson. Thank you for your watching.